Have you ever stopped to ponder the truly immense? Did you know there's a number so big, so vast you can never reach it? It's a concept that stretches the mind, a boundary that forever recedes as you approach. Think of the largest number you can imagine. Really push the limits of your numerical imagination. Is it a million, or perhaps a billion? Maybe you've ventured into the realm of a Googleplex. Even a Googleplex, with its seemingly unfathomable size, a 1 followed by a Google of zeros stretching further than the eye can see, is still not infinity. It's a stepping stone, but not the destination. Infinity isn't a number you can write down, no matter how much paper you have or point to. It exists beyond the realm of countable objects. It's an idea, a concept, something that goes on forever, without end or limit. Imagine counting starting from 1, 1, 2, 3, and so on. You could count your whole life, dedicating every moment to the task, and never run out of numbers. There would always be another one waiting. Your great-grandchildren could keep counting, continuing the endless sequence, and still, there'd always be another number just beyond their reach. That's the core of infinity, the essence of its boundless nature, a journey with no destination, a path that stretches on without end, always one more step, one more number, one more possibility. In math, to represent this concept, we use a special symbol for infinity. It looks like a sideways 8, a continuous loop that never breaks. This symbol lets us talk about things that never end, about quantities that are limitless. Infinity is like the word forever, an abstract idea that's hard to grasp fully. You can't measure it with a ruler or a measuring tape, but you know what it means. You understand its implications. It helps us understand everything, providing a framework for comprehending the vastness of existence. From tiny particles, the building blocks of matter, to the vastness of space, the seemingly endless expanse of the cosmos. Our brains are used to things with clear beginnings and ends, finite experiences, school days with their start and end times, TV shows with their opening and closing credits, loaves of bread, which are eventually consumed. But math lets us explore ideas, concepts that go beyond our everyday experience, transcending the ordinary. It gives us tools to think about, to grapple with the endless and the eternal, the infinite and the boundless. So, get ready, prepare yourself. We're about to journey into the mind-bending world of infinity, a place where the rules are different. Infinity isn't just big, it's not simply a large quantity, it's bigger than any number you can imagine, no matter how vast your imagination may be, because you can always add one more. There's always room for expansion. It's a fundamental concept, a cornerstone of mathematical thought that changes how we see the world, offering a new perspective on reality. Consider this. Let's delve deeper into the fascinating world of infinity. Infinity. The very word conjures images of vastness, of something without end. But what is infinity really? It's a concept that has puzzled mathematicians and philosophers for centuries. Infinity isn't just the biggest number, it's not a number at all. It defies simple numerical representation. If it were, you could add one to it and get something bigger, which would immediately contradict its supposed bigness. But you can't. You simply can't treat infinity as a standard number in your calculations. Infinity is more like a direction you can travel in forever, a path that stretches out without any conceivable end. It's not a destination, a place you can ultimately arrive at and say, I'm here. Imagine walking on a road that never ends, a road that continues on, seemingly without limit. No matter how far you go, there's always more road ahead, always more distance to cover. That's potential infinity. The idea that you can always continue, always progress. It's the process of always being able to add one more, to extend the sequence, to push the boundaries further. If we treat infinity like a number, we run into trouble, and mathematical paradoxes begin to emerge. For example, what's infinity minus infinity? The question seems simple, but the answer is far from straightforward. It doesn't make sense in the traditional arithmetic framework. It's like asking, what's forever minus forever? How do you subtract something that has no end? The question itself is confusing because it applies finite operations to an infinite concept. Infinity needs its own rules and way of thinking, a different set of axioms to guide our understanding. Think of a tall building versus the sky. A structure that reaches great heights but is ultimately limited. A building has a top floor, a defined limit to its vertical extent. But the sky just keeps going, stretching out into the cosmos without any discernible boundary. Any big number is like a building. It might be incredibly large, but it's still finite. Impressive, but finite, with a clear and defined endpoint. Infinity is the endlessness that contains all those numbers, the boundless expanse that encompasses everything we can conceive of, and goes beyond them, extending into realms that are beyond our immediate comprehension. It's not a place you arrive at, a final destination to be reached, but the fact that you can always go further, that there's always more to explore and discover. This is why infinity is so important in math, because it allows us to grapple with concepts that extend beyond our everyday experience. It lets us think beyond limits, to explore the consequences of unbounded growth and endless possibilities. It's a unique concept that changes how we understand size, forcing us to reconsider our notions of scale and magnitude, space, challenging our perceptions of distance and extent, and possibility, opening up new avenues of thought and exploration. Infinity is the sky, not the building, the boundless expanse, not the limited structure. And that's what makes it so fascinating, so endlessly captivating. It's a glimpse into the truly limitless. We can't hold infinity, but we can imagine it. Picture a magical pizza that never runs out. Take a slice and another appears. You and your friends could eat forever, or imagine Russian nesting dolls that go on forever. Open one, there's always a smaller one inside. Infinity isn't just about getting bigger, it's also about getting smaller and smaller, endlessly. Think of a book with infinite pages. You could read a new page every day and never reach the end, or stand between two mirrors and see your reflection stretch on forever, each one smaller and fainter. These are glimpses of infinity in everyday life. Infinity is endless novelty, endless exploration. It's the promise that there's always more to discover. Even though real mirrors and pizzas have limits, these examples help us picture the infinite. Infinity is both outward, bigger, and inward, smaller and smaller. It's a journey with no final stop. That's what makes infinity so captivating. We first meet infinity in the counting numbers 1, 2, 3, and so on. Is there a biggest number? No matter what you say, I can always add one more. That's why the set of natural numbers is infinite. We can't write them all down. There's no end. This is our first encounter with an infinite set, a collection with no limit. It all starts with counting and realizing you never have to stop. Now think about whole numbers, positive, negative, and zero. This set is also infinite, stretching in both directions. Some infinities are even bigger than others. The infinity of all points on a line is bigger than the infinity of counting numbers. Mathematician Georg Cantor proved this mind-blowing idea. Infinity comes in different sizes, and that's just the beginning. Counting opens the door to a world where even infinity itself has levels. Infinity isn't just about getting bigger, reaching for the stars, or counting endlessly upwards. It's equally fascinating when we consider getting smaller too. It's about delving into the infinitesimal. Let's imagine a pizza, a classic example. Now keep cutting it in halves, quarters, eighths, sixteenths, and so on. You can keep dividing forever, theoretically of course. You'll never truly run out of pieces. They just become smaller and smaller, approaching zero in size. Now consider any two numbers, even seemingly simple ones like 0 and 1. Between them, there exists an infinite number of fractions, 1/2, 1/3, 1/4, and so on, endlessly stretching towards both 0 and 1. There's always another number, another fraction lurking in between, waiting to be discovered, no matter how closely you examine the number line or how powerful your magnifying glass. This is what we call an infinity of density, an uncountable number of possibilities, all packed into an infinitesimally small space. This concept forms the very basis of calculus, a powerful tool that allows us to understand and model change and motion in the world around us. For example, to accurately measure a car's instantaneous speed at a precise moment, we need to divide time into smaller and smaller, almost imperceptible pieces, effectively approaching an infinitely small, fleeting moment in time. This ingenious idea allows us to solve complex problems that would otherwise remain completely intractable. It's the fundamental principle behind how we calculate complex curves, the elliptical orbits of planets, and the intricate dynamics of fluid flows. But infinity, especially in this context, also leads to fascinating paradoxes, such as Zeno's paradoxes. Consider a runner. To reach the finish line, a runner must first cross half the distance, then half of the remaining distance again, and then half again, continuing this process forever. So, logically, how can they ever actually reach the finish line and complete the race? The surprising answer is that adding up an infinite number of these increasingly tiny pieces can, in fact, still result in a finite, measurable result. The concept of infinity in fractions beautifully demonstrates that endless division, breaking things down into smaller and smaller components, is just as powerful and insightful as endless addition. It represents a different, perhaps less intuitive, kind of infinite. One that permeates everything, existing even within the seemingly simple spaces between the numbers we readily recognize. This is the captivating magic of the infinitely small, the infinitesimal. And remarkably, it's all around us, shaping the world in ways we often don't even realize. Look up at the night sky. The stars seem endless. Is the universe actually infinite? We don't know for sure. Some theories say space is finite but unbounded, like the surface of a sphere. Travel far enough and you end up where you started. Others suggest the universe truly is infinite, stretching forever in all directions. In an infinite universe, anything possible must happen somewhere. Maybe even another you, reading this script. Time might also be infinite. The future could go on forever, leading to the heat death of the universe, endless cold and silence. Whether space and time are truly infinite or just vast, thinking about infinity helps us grasp the scale of the cosmos. The observable universe is huge, but it might be just a tiny bubble in a much larger, possibly infinite reality. Infinity connects math to the fabric of the universe. It pushes the limits of our imagination. Mathematician David Hilbert imagined a hotel with infinite rooms, all full. A new guest arrives. The manager asks every guest to move to the next room, freeing up room 1. Now the new guest has a place, even though the hotel was full. The next night, an infinite busload of guests arrives. The manager asks each current guest to move to double their room number, room N to room 2N. Now all the odd-numbered rooms are empty, ready for the new infinite guests. The hotel fits an infinite number of new guests, even when it's full. This is Hilbert's hotel, a paradox that shows how infinity breaks our usual rules. With infinity, there's always room for more. Our normal ideas about size and space don't work here. Infinity can absorb infinity, and still be infinite. It's a place where logic gets turned upside down. Hilbert's hotel is a window into the weirdness of the infinite. It's a reminder that infinity is stranger than we can imagine. With infinity, math gets weird. Infinity plus infinity is still infinity, like pouring an infinite bucket into an infinite ocean. Multiply infinity by 2, a billion, or any number, and it's still infinity. Hilbert's hotel showed us, infinity can be split, doubled, or added, and it never runs out. But some operations are undefined. Infinity minus infinity, sometimes it's 0, sometimes it's still infinity. It depends. That's why mathematicians say it's undefined. Dividing infinity by infinity is also tricky. It depends on which infinities you're talking about. Some infinities are bigger than others, and that matters. Mathematicians use special tools, like limits, to handle these cases. Infinity isn't simple. It has its own rules and surprises. It's a rich, complex field with beautiful logic. The infinite is a world where the usual rules just don't apply. After all this, is infinity real, or just an idea? We've never seen an infinite number of objects or measured an infinite distance. Maybe infinity is just a tool, a symbol in math, like a perfect circle. But some argue infinity is real. The set of all numbers is infinite, and maybe the universe is too. If the universe is infinite, then infinity is part of reality, not just our imagination. The fact that we can't see all of it doesn't make it less real. Ultimately, is infinity a powerful invention of the mind, or a feature of the cosmos? Maybe it's both. A bridge between thought and reality. Whatever it is, infinity is one of the most profound ideas we've ever conceived. Consider this.